terms will be involved in the solutions here. So those terms already I have learned in the 11th class in some basic concepts. Again, we'll revise that one. First thing, if you observe in our daily life, we come across many number of substances. There are number of substances are there. Daily we are using that one. See, if you see this one, sugar, which is dissolved in the water, air, isn't it? Having a mixture of gases, a paste is a molten type of phase it is, molten phase it is. Now this is the liquid phase and this one is the air actually. So there are number of what? Most of the substances are mixed containing two or more pure substances. Here if you observe molten state, many number of substances were added here. To make this aqueous solution, we added some salt. We have taken something mixture something like this. Air is a mixture actually. Now can you guess which of these are solutions? Sugar is a solution, isn't it? What about the brass? Brass is called solution or not? Tell me. Who first? Is brass is called solution or not?
Yes, sir.
Brass is a solution. It is an alloy mixture of what? Copper and zinc. Copper plus zinc is a solution. Mixture of what? Elements also comes under solution. Mixture of what? Sugar and water also comes under solutions here. Isn't it? Brass also what? Solution. Now what about this one? Air. Air is called solution, better. Here air is called solution.
Yes, sir.
Definitely, it is also called solution, isn't it? Air is also what? A solution only. Mixture of nitrogen plus oxygen and remaining minute gases comes under what? Solutions only. All these are what? Solutions only. They can be taken as examples for what? Solutions, isn't it? For example, you may get a such type of questions in which of the following are solutions like that, right? What is the meaning of solution? What is the meaning of solution means? How do you say it? The definition of the solution? You can see simply we can say what happened. Homogeneous. Homogeneous means what happened? The two phases. Everything is what in same phase. Okay. Homogeneous means generally what happened? We will mix actually two or more components to make the solution, and everything looks what happens same phase. Homogeneous cannot be separable. Mechanically, you can't separate. For example, you have mixed what happens, sugar and water. Can you separate sugar from the water? Can you visible that one? Naked eye, can you see what happened? What is sugar and what is water? Water is. Can you separate that one? No. So that is homogeneous. Whatever the ultimate phase you are going to get, that is same phase only, isn't it? So the homogeneous mixture of two or more than two components generally called as solutions. The two components you can take as solid, liquid and gas. For example, nitrogen plus oxygen is a homogeneous mixture. Alcohol plus water is a homogeneous mixture. Otherwise, you add salt in water, homogeneous mixture, isn't it? So to say homogeneous mixture, compulsory what is the condition? You have to write that. To write the solution definition, compulsory we need homogeneous. It should be homogeneous. The solution must be homogeneous in nature. What is homogeneous mixture? I had already told you. Composition and physical properties are uniform throughout the mixture. They're having same properties. For example, take a spoon of sugar and mix thoroughly in a glass water. I've taken what happened? Sugar and mixed in water. Now what happens after that? Now check whether the taste of every drop is same or not. For example, you check some drops over here after dissolving. Do they are having same taste or different? Definitely they will have same taste. This is the sugar solution you will get. This is uniformly distributed. Which one? The sugar is uniformly distributed. It mixed thoroughly in water. Now what is solution? solute plus solvent. Now, which is called solute and which is called solvent, beta? Anybody? Which is called what solute and which is called solvent?
So the component which is in largest amount is called solvent, and the
Yeah.
content which is in less amount is called solvent.
Generally, what happens? Solvent will have less content, smaller quantity. Sorry, solute will have smaller quantity. Solvent will have large quantity. You can also remember like this. How many letters are there, beta? 1, 2, 3, 4, 5, 6. Here. 1, 2, 3, 4, 5, 6, 7. Anybody get confused what happened? What we have to see here? Number of letters. You see how many letters are there? 7 letters. Large. 6 letters. Small. So smaller will be solute. Larger will be solvent. In this way we can remember. Isn't it? Right. Next what? Identify the solute and solvent in the given solution. First of all, a solution of 5 grams of salt, 1000 ml of water I have taken. 5 grams of salt I have taken, 1000 ml of water. I got a solution now. In this case, what will be the solute, beta?
Salt.
Now, how do you say it is salt? Because grams and ml different, no?
Salt.
Grams and ml different, no? In that case, what you have to see, resulting will be in liquid state or solid state, beta? Resulting solution will be
Liquid state.
liquid state. Though definitely that liquid state is what? Large content, no? So definitely it will be solvent. Solute will be definitely what? Salt, and solvent will be definitely what happen? Water in this case. Then resulting solution will be what? Whatever you order. Resulting solution will be in liquid state. So which is liquid state in that one? Water. So water will be solvent. Generally we can say 5 and 1000 definitely what happened there. What? It is a little bit. This will be larger content. Solution of 5 ml of ethanol, 5 ml of water. Here we can easily identify. Which is solute, beta, in this case?
Ethanol.
Ethanol will be the solute here, right? Next. In the above two solutions, the solvent is water. Now, whenever solvent is water, beta, you have to call that one aqueous solution. Whenever water is solvent, call that one aqueous solution. Whenever alcohol is solvent, what you have to call? Whenever alcohol is solvent, what we have to call? Which type of solution it is?
Alcoholic.
Alcoholic solution. Alcoholic solution we have taken in the elimination reactions. In organic chemistry, when you take alcoholic solution, we got elimination reactions. I'm writing over here, just small thing. CH3, CH2, chlorine I have taken. If I take aqueous KOH, anybody, what is the product name? Aqueous KOH, solvent is water. Same reactant, treating with what here? Alcoholic KOH. Alcoholic KOH. Okay, this is aqueous KOH, solvent is water. Alcoholic KOH, solvent is alcohol. This we have studied where in the halogen compounds. Anybody? Here it is substitution reaction, SN2 reaction. This one will be the elimination reaction. Now tell me the name of the products we are going to get, because these are very, very important in examination point of view. Whenever you get chance, you should discuss this one.
Ethanol.
KOH, what will be the product data?
Acid.
This will be what? Ethanoic acid. Ethanoic acid. Now what happens, beta? Cl will be replaced with what? OH. Now is it ethanoic acid or ethanol, beta?
Ethanol.
Ethanol, right? It is very simple. Now when you take same place in terms of what alcoholic KOH, if I take what alcohol as a solvent, solute is what KOH only. Both the case solute is KOH. If I take alcohol as a solvent, now elimination reaction takes place. Now tell me, dehydrohalogenation takes place. Dehydrohalogenation. D means removing, hydrogen, halogen you are removing. Now what will be the product, beta?
Ethene.
Yes, ethene. Remaining one, nobody is responding. Isn't it? Ethene it is. These are very important for examination point of view. Can you give an answer for this one? Definitely. Do first, beta. A solution is gas mixture of two.
B.
Homogeneous.
Heterogeneous. Homogeneous beta. Homogeneous. This is important question beta. Very important. Next. Homogeneous mixture implies what type of appearance?
Uniform.
Uniform only. You get a uniform appearance we get actually. Next. The component present in small quantity is called what?
Solute.
Solute.
Right. A solution of 5 grams sugar and 5,000 ml of water. The solvent will be?
Water.
Water.
Very good. Very good. Aqueous solution in which one contains, which is the correct one?
Water.
Water as solvent.
Water as solvent.
Water as a solvent. Next. We take now next thing is classification of solutions better. How to classify the solutions. So in examination point of view, classification of solutions is important. Right? Solution can also be classified based upon what criteria? Let me see this one. First thing, number of components here. Thing is number of components. This is not very important for us. Examination point of view, not at all important based on number of components. For example, if it is, you have two components, one solute, remember beta, always solvent will be one only. You may have two or more solutes, but solvent will be one only. Now, if you have two components, one solute, one solvent, that is called what? Binary, isn't it? Three components means what? One solute, two solutes, one solvent. That is called what? Ternary. Four means what happened? Three solutes, one solvent. That is called what? Quaternary. So in that case, what happened? Bi, ter, quaternary. Isn't it? So bi, ter, binary solution, ternary solution, quaternary solution. So in this case, what happened? 3 plus 1. In this case, 2 plus 1. In this case, 1. First one will be the solute, last one will be the solvent, isn't it? But binary, ternary, quaternary, we can call this one. Quaternary solution. So generally in our syllabus, what happened? We'll see most of the case binary solutions, in some case what happened? Ternary solutions, right? You see, we're adding what happened? Two solutes, the what? Solvent. Here only what? One solute, what happened? One solvent. Next, what we see that is important. Physical state of solute and solvent. This is important. Based upon the physical state of solute and solvent, we can explain the solutions classification. Let me see this one. Physical state of solute and solvent. This is in the textbook also. You can observe in the textbook also. Let me take first of all, solute is gas and solvent also gas. In this case, gas in gas we can call this. What is the name we can call? Gas in gas. Okay, solute is gas, solvent. Anybody example? What is the example we can give for this one? Which example we can take here?
Air.
Air.
Example beta? Air. Speak louder. I think you can take nitrogen plus oxygen, right? You see, nitrogen plus oxygen can be taken as best example for air. Next, we'll see what gas in liquid. Now, solvent is more beta. In this case, we can call gas in liquid. Any example? Can we give? Gas in liquid.
Foam.
Foam. Foam we can take.
So water.
Yes, soda water. Soda water. Soda, isn't it? Soda water comes under this one. Oxygen in water also we can take. Carbonated drinks, isn't it? Soda water comes. Best example, soda water. Carbon dioxide in water. Or oxygen in water. Generally, oxygen in water we see, no? Because of this oxygen only, the aquatic life can sustain their life. Because some oxygen is dissolved in the water in the sea, otherwise river, or water bodies. So you can take this example. Okay. Otherwise, soda water you can take. Foam you can't take better. Right? Any air dissolved in the liquid that you can take in this case. Next, we will see the gas in solid. So gas in solid is a very rare case beta. Generally, you don't observe this one. Now, this we take in which reaction? Anybody? This type of example, you have taken some reactions. Could you explain this one? In which reaction we have taken this one? Hydrogenation. CH2 double bond CH2 hydrogen in presence of nickel, platinum or palladium, we get what? Ethane, CH3, CH3. Now, if you observe what happened, both are gases, right? This is gas and this one is a gas. To both undergo to reaction, what happened? They need some surface. So nickel act as a surface for them. On the surface of the nickel, what happened? The reaction could take place. So here it is called what? Any gas, isn't it? Which is adsorbed over the solid surface. Hydrogen absorbing on the nickel. Or preparation of ammonia. Nitrogen plus hydrogen gives rise to ammonia in presence of what? Iron catalyst. So generally what happens when gaseous reactions, remember better, gaseous reactions in which catalyst is a solid. Gaseous reactions in which catalyst is a solid. So such type of reactions we get in the gas in solid. Next, liquid in gas. Liquid content is less, but gas content is more. This is called what? Liquid in gas. Could you give one example for this one? Liquid in gas. Liquid content will be less, but gas is more here. General example, you can give me this one.
Fog.
Yes?
Fog, sir.
Moisture. Moisture we can take here. Moisture is present in the air. Now air content definitely what happened more here. And the liquid content will be what? More in this case. Liquid content will be more in this case. Isn't it? Moisture. Especially when you go to beach areas, in that case, moisture will be more. Isn't it? Because water content is more. In that case, what happened? Moisture will be more in air. But normal areas, what happened? Water content will be less, but air will be more in that case. That is the reason when you go to beach areas, what happened? We get suffocation because of what? More moisture in the air. So this one, if you observe what happened, it's an example. Next, liquid. Best example, can you give liquid? Alcohol in water, right? When you dissolve some alcohol in water, what happened? We get this one, right? Next, this one is very simple better. Liquid, what happened? Two liquids, if you mix, what happened? No, one more thing better. One more thing you have to remember. Benzene liquid, right? Benzene is a liquid. Adding some into water. Water I have taken also liquid. Now this one is a solvent. I have taken more water. This one is a solute. Can you get solution here?
No.
It's called solution. Benzene, if you add into water, do you get a solution? Is it called solution?
No.
Why?
Because it is insoluble.
Because it is heterogeneous. Insoluble means heterogeneous. I told you homogeneous mixture should be. Solution must be homogeneous. You cannot separate that one. Easily we can separate because it is insoluble. Here water layer will be there here. Here benzene layer will be there. So you can easily separate these two here. Understood here? So remember, you can't take all the liquids. Why I am saying here? You can't take all the liquids. See, benzene is non-polar beta, whereas water is what? Polar. How do they soluble? Impossible. But you see what happens? Sugar and water. Of course, water is solid state. Water is liquid state. Sugar is what? Solid state. Of course, these two are heterogeneous, but resulting solution you have to see. You can't see these two. Whatever the resulting solution you are going to get, that you have to consider. Next one, if you observe what happened, liquid and solid. Liquid content is less, but solid content is what more? Can you give one example for this one? Amalgam. Amalgam is the best example. Amalgam is the best example here. Sodium amalgam. Or something what happens, silver amalgam, zinc amalgam. The amalgams comes under what actually? Liquid solid. Where mercury is what here? Liquid state. In this case, the liquid state is mercury. Next, solid and gas phase. Gas is more, but solid is what here? Less content in. Solid in gas phase. In this case, what happened? Iodine If you heat iodine. Camphor, if you heat, just heat, what happen? Camphor or iodine. So these two are sublimable compounds beta. You take only sublimable, don't take all the solids beta, which are sublimable. What is sublimable?
Evaporate on
solids
heating.
which
They directly convert into what here? Vapor state. Without liquid state, they directly convert into vapor state here. So in that case, what happened? The camphor, when you heat, what happened? They convert into vapor and they will be a mixture with what? Air actually. Right? Understood better. You don't take what? All type of solids which are having what here? Evaporation. That means sublimation. Now, can I take this example? Smoke. Smoke. That means what happens? Smoke particles in air. Smoke in air. Shall I take what happens? Solution here? Is it possible? Dust in air. Dust in air. Shall I take solution?
Sir, it is a heterogeneous
no.
mixture.
Dust and air easily separable, easily distinguishable. It can be physically distinguished. You can easily see dust in air. So dust in air, don't take what happened. Dust is solid. Air is what? Gas. Now don't take dust in air as a solution here. Next. Solid liquid. This is number of times you have taken. Solid liquids. Any sugar solution, salt solution, you can take that one. So this is no need to discuss. Now solid beta. Both are solids. Both are solid. Solid and solid. In this case, what happened? Can I take what happened? Mixture of what happened? Two different type of dal. Pulses, can I take? Pulses. Mixture of pulses, can I take?
No.
Mixture of pulses, can I take beta in this case? You can't take.
No, sir.
You can't take, you can easily separate that one. So what I can take here? Metal alloys. Just now we discussed alloys here. Copper plus zinc is called what? Brass. Copper plus tin is called what? Bronze, like that. German silver. Like that, you can take many number of examples here. Okay. So the examination point of view beta, these are very, very, very important. Physical state of solute solvent, we can easily list. So in your textbook, the classification is there. So all of you note in your notebook. Okay. So that is are very, very important. What type of the solution is soda water? What type of the solution is soda water? What type of solution beta soda water?
Gas in liquid.
Gas in liquid.
Aqueous solution and gas in liquid, right? Bronze is what type of solution?
Solid in
Solid
solid.
in solid.
Solid in solid, right? Very good. Brass also comes under the same example you can take. Brass, a homogeneous mixture, because copper, and when you mix, what happened? Copper is different, zinc is different better. But when you mix, what happened? The resulting solution properties, what happens? Same here. So you can't separate copper, zinc, isn't it? That is different method. By heating and different method, you can separate that is a different. But naked eye, we can't do no. German silver is also what happened? Solid in solid type, because it's alloy. Right. Metal amalgam is what type of solution beta? It's a very important.
Liquid.
Liquid in solid.
Amalgam is liquid plus solid. Soda water is what type of solution beta?
Binary.
Binary solution, right. Sublimation leads to the formation of what type of solution beta? Sublimation leads to what type of solution? Gas and solid, gas in solid. Sorry, solid in what type of solution we get? Solid in
Gas.
solid in gas, right? This is very simple, no need to give. What should be the answer beta in this case?
All of these.
All of these.
It's the binary solution, solid in liquid, aqueous solution. So this is about small introduction about what actually. Now let me take the concentration bit. We'll take now here concentration. Students are there only 33.